Hello. So this is topic 3, and in topic 3 we did the area between two curves and volume. And we did volume using the disk method, washer, and cross sections. The disk method and washer method are kind of the same. It's just that with the disk method, there's no space. So you don't have a little r. So for example, if I'm doing, this figure, this is my r. So everything is stemming from pi r squared. So one of the mistakes that was really common on that test is people just sort of threw pi into all of their answers. You have to think about whether you have a pi in the formula or not. You will for the disk and washer methods because you're rotating and creating those circles around the rotation axis. But when you get down here to like cross sections, you're not. And that's the one where I kind of showed you guys online how you would be able to go, hey, I have a square and it's building up from this piece in my in my graph. So just be careful about how much you use pi. You only want to be using it if there's rotation. So the difference between washer and disk is simply that in a picture like this, my graph goes all the way to what I'm rotating and there's no hole in the middle. Because like the difference in life between a regular disk or a washer is that a washer has an open center. It's like a donut shape. And so in that case, you need to take away that little r to create that hole. So if there's no space between what you're rotating and the rotation axis, you will not be using big R, little r. You'll just have r squared without a second little r. So the information is kind of put together at the top here. Let's take a look at the question from last year. This is a no calculator, which only becomes annoying in one of the problems because there's a lot of fraction stuff to do. So in part A, we have two functions. We have f of x, which is x squared plus 2, g of x is x squared minus 2x, and then the graph is over here. So we've got f of x here, we've got g of x here, and then they label each shaded region R and S, so you don't have to generate your own graph, which is very helpful. Okay, so in part A, it says, let R be the region bound by the graph f and g from 0 to 2, as shown in the graph. So that is from 0 to 2, and that's going to be this space here that they have labeled R. Now, what are we actually supposed to do? We are supposed to write, but do not evaluate. So that's one of the things you really want to watch for. Are you asked to evaluate it or not? Because if you start evaluating when you didn't have to evaluate, you're going to run short on time. We're going to be writing an integral expression that gives the area. Okay, area does not involve rotation, so I'm not going to have a pi. I'm just going to put top minus bottom. So this is our area up here. This is our two-dimensional area. Top curve minus bottom curve, because all I'm doing is finding how tall this is, and then I'm adding those all up, and integration adds those all up. So if I'm going from 0 to 2, I'm going to integrate from 0 to 2. I'd probably start off with like area equals from 0 to 2. And if you look, the top of these is going to be f, and the bottom of these is function g in that region. So I would go ahead and have my f of x minus my g of x, and then that whole thing is my top minus bottom. And then please, 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 whenever you write an integral, remember to put at the end the dx, dy, d, whatever the variable is that you are using. Speaking of variables, that's one of the things that is tricky about this is thinking, am I writing my equation in terms of y or in terms of x? And the only time you have to switch that is as they go to different axes. And so that's up here too, kind of reminding you to think about, horizontal, where did that go? I thought I saw it. Here we go. Horizontal axes of revolution versus vertical. So if I'm rotating around this, as you can see this little arrow, then I'm going to be doing my function in terms of x. But if I'm rotating around a vertical line, so it's actually like horizontally rotating around, then I'm going to be doing that function in terms of y. So think about that when you're doing this section. And then same down here, when you're doing the cross sections, if it says perpendicular to x, you're actually going to use x because you're going this direction and you'll just be doing your normal f of x stuff. If it says taken perpendicular to y, you're going sideways, and sideways always means you're going to have to write everything in terms of y. So sort that out in your brain, because that's one of the tricky bits, and again, a really popular way that kids missed points when we had this test. So all I have to do for A is what we've already done, because it says write but do not evaluate, and then it tells me that the integrand is going to be 1 point, and then here having like these proper what do you want to call them, like the upper and lower bounds. Okay. Then, and you can write it like this, you guys. You can write f of x minus g of x. You don't have to do this. Alrighty? So you could, I mean, if you wanted to have from 0 to 2 of x squared plus 2, which is f of x, minus x squared minus 2x, and then that whole thing, dx, you could do that. You could do x squared plus 2, distribute that negative carefully. I feel like this is adding more opportunities to make a mistake, however, and you would end up with an integral from 0 to 2 of 2x plus 2 dx. So that's not wrong, it's just not necessary unless it specifically asks you to do that. Okay. So then in part B, and I might end up erasing all this stuff I'm writing because I don't want to write over what I'm doing, or then there's not a ton of room. Part B, oh good, lots of words. S is the region bound by the graph of G and x-axis from 2 to 5. That's what I figured as shown in the graph. So here's S. So it's this to here, and then that. That's the boundary. And keep in mind that the only thing touching that is function G. It is not actually formed by function F at all. Alrighty, we are going to do volume with, it says the region S is the base of a solid. So we're talking about volume. For the solid, at each x, the cross section perpendicular to the x. So as you're reading that, you're like, okay, no pi, because I'm not rotating, so I'm not doing a circle. The only time I would use pi in a cross section is if I'm going to be using semicircles as my cross section. It says the cross sectional perpendicular to the x-axis. So thinking back here, if I'm doing cross sections perpendicular to the x-axis, I am writing my function in terms of x, which is comfortable for us because that's the way we usually do it. All right. And then we are using rectangles, it says, with a height equal to half the base. Okay. So that means here, that is going to be the base of our rectangles, and they are only going to be half as high. So if the bottom, so actually my rectangle is not drawn to scale. It's saying if the bottom of it is here in the region, it's only going to be half as high as it is the base. So what is the base of that? Well, the base of that is going to be the space between this function and the x-axis, which is actually just the function's value. So I am going from here to here, which is 2 to 5. I am finding a volume, so I'm going to write that out. Okay, if I was doing this rectangle, this down here would be the function's value, and the side would be half of the function's value, if that makes sense, because it says it's half as tall as it is wide. So if I did 1/2 gx times g of x, I would have 1/2 times g of x, that whole thing squared, dx. And you could certainly put the 1/2 out in front. That would be okay too. Now this one says to find the actual volume and show your work. So here I am going to have to go ahead and put in for the g of x what that function is. So looking up here, that's going to be x squared minus 2x. And then I'm going to have to just do my work from there. So if I take the 1/2 out in front, and then I square this out, so you'd be foiling x squared minus 2x times itself. I'm just doing this part right here. I'm keeping the 1/2 out in front. I'm still going from 2 to 5. I'd end up with x to the 4th minus 4x to the 3rd plus 4x squared. And since the whole thing is my function, I put parentheses around it, and then I remember my dx. Now I'm going to do my integration or antiderivative. This one I don't need a calculator for. I'm going to have 1/2 out in front. I'm just going to use the power rule. So I'm going to add 1 here and get x to the 5th divided by that new power. Here, if I added 1, it would be x to the 4th, and then that 4 would be on the bottom. But if I do that, these will cancel. So it just ends up being a plain x to the 4th. Here, if I add 1 to the power and then divide by the new power, I get 4x to the 3rd over 3. And now I no longer show that integral sign. Like, you want to have it in here as you're doing it, but once you integrate it and do the antiderivative, you don't write the integral sign anymore and you don't write the dx. You either use a straight line here and here, or you just use the brackets. Now the fun math begins, and this is the one that's kind of annoying to do without your calculator. You are going to be going from 5 to 2. So you're going to have a half, and then you're going to plug 5 in here, 5 to the 5th over 5 minus 5 to the 4th plus 500 over 3. That whole thing minus 32 over 2, because I'm running out of space. Excellent. So I'm just going to write it below. I would be subtracting what I get when I plug in 2. So I would have like 2 to the 5th over 5 minus 2 to the 4th plus 4, 2 to the 3rd, all over 3. And so without argument, that is completely annoying. Now, one thing to really keep in mind is that this subtraction sign in between them is actually going to, ultimately impact each sign. I'm not going to take the time in the video to keep going through all of the math. You can follow it along if you want to on the online version, but you end up with like 414 all over 5, which arguably is pretty brutal, but you can make your way through it. You can just keep going forward. Okay, so like you have to kind of use some common sense too, though. Like if you're doing this part and you're like, my gosh, this is so big. Well, 5 to the 5th over 5 to the 1st can reduce to 5 to the 4. And then the next thing you're doing is subtracting 5 to the 4. So those cancel, right? So like look for opportunities in these problems where you're like, these numbers are so huge. Try to look for opportunities to see if those are going to somehow shake loose a little bit more easily because they know you don't have a calculator. Okay, so in that particular problem, going through, you are getting 1 point for showing your integrand, which is this whole thing. 1 for showing the limits, which is these guys, right? And this point would come from having the half, the parentheses, the square, the dx, the whole 9 yards. And then the antiderivative. So here you're going to have a point for showing that you got that appropriately, and then here. And we can look at some rubrics together to see like how do you get points if you make the mistake in the very first step. And it is possible. So we'll look at how they go about grading that, which is a pretty complicated thing. But we'll take time in class to do that before the test. Probably not before our test Friday, but more before our test, like the actual AP test. All right. So that is part B. Part C, I actually think I just have to erase my part A. If you need the answers, they're on the solution, so you can do that just to make room. So in part C, right, but do not evaluate, an integral expression that gives volume of the solid generated when region S, which we already talked about, rotated, hello pi, around a horizontal line at y equals 20. Okay. So I'm going to get rid of all this stuff that I wrote on my graph so I can start over again. If I have a horizontal line at y equals 20, that's right here, and I'm rotating this around it. And in this case, I'm going to have a washer method because I'm going to have a space. And anytime you have a space, you're going to need the washer method. I have a space between my line of rotation and my actual region. So let's kind of remember when we have these, we're looking from, how far away for big R. So if you look at this as big R, this entire big R is 20 away from this line because this is the axis and this is 20. So in this problem, my big R is going to be 20. How about my little r? Little r is going to be this part here that I'm taking away. So to get little r, I have to take the big R, which was 20, and take away the part under the function, which is going to be the actual g of x. So little r is going to be what's left over when you take the whole thing, which is 20, and subtract this part that's under the graph. So my little r is going to be 20 minus the function g of x. Okay, so we are rotating it, excuse me, and we're going from 2 to 5, right here, 2 to 5. So my volume is going to be pi, because this one's a rotation. I'm going to go from 2 to 5. I need my big R squared, which you're not expected to do, minus my little r, which is 20 minus g of x. And that whole thing is squared, because this is big R squared minus little r squared. But you are doing the integral of that whole thing. So again, since I already have parentheses, I'm either going to put another set of parentheses around everything, or I'm using brackets just to differentiate it. Oops, dropped my Apple Pen. BRB, kids. All right, I'm back. Well, I'm actually already done, so it's okay, because it said I didn't have to evaluate it. So this, my friends, is my actual answer. What do I get points for? The form of the integrand, meaning do I have the proper r squared minus, do I have r squared minus big R squared minus little r squared? That's what they're looking for when they say the form. Then when it says integrand for a second point, it means did I actually get the right r and the proper little r? So they're looking specifically, did you have the right things? And then they're looking at all of this business. Do I have the right limits and that constant of pi out in front for my third point? So in this particular one, you had 2 points here, 3 points here, and then 4 points here for your 9. So again, hopefully that helps. I would definitely look through these and make sure, if you're like, I'm pretty good at the ones where you're using X, but I'm not very good at the ones where I'm using Y, then go through and find somewhere you have to write everything in terms of Y and practice those. Because again, I'm asking you to practice enough in each section that you feel confident. So what I would do is find the kind of problem that you're most scared of in that section and practice that one, not the easy ones. Practice one where you're like, this one's the thing that I have the most trouble with. Utilize the online tools to help you, and hopefully you can feel more confident. Thanks, guys. Bye.